This is a continuation of the lecture on central angles and arcs, but now continues on to sector area rather than just looking at arc length. Now the idea here is, first of all, a sector is sort of a piece of the pie. It's an area. It's not a length around the outside. It's an actual piece of the circle itself, sort of the area in here. So this yellow portion is a sector. And we know we can get the area of the entire circle. Its area is pi times radius squared. And what we can do is get a sector area formula in the same way we got an arc length formula. That is, rather than looking at the whole circle, what if we only care about 180 degrees out of 360? So this angle here was halfway, and we only want to look at then half the circle, right? Or maybe the angle in question, which goes with this arc, is actually 90 degrees. And so really all we're interested in is a quarter of the circle, because 90 over 360 is a quarter. Or perhaps this angle, this is more plausible, maybe more like 60 degrees. So this is really only 1/6 of the circle. Or perhaps it's 150 degrees, which is then 5/12 of the circle. So if we want to get just that portion of the circle we're interested in, we've got to take this fraction and multiply it by the total area. So here's our area formula for a sector. It's the angle, the central angle that is, over 360, the entire circle, times pi r squared, just to give us, this is the portion we want of the entire circle. Now one other piece here, which gets a little trickier later, is what's called an arc segment. An arc segment is that little thin strip which lies between the triangle you get from a sector and the edge of the circle. So for instance, here I've got this sector. If I draw straight across right here between these 2 points, then this arc segment is this area out here. That's called an arc segment. And so to get the arc segment, you simply have to find the area of the sector, this whole piece of the pie, and subtract this triangle. Subtract the triangle, and whatever you're left over with is your arc segments. We'll get to some of those in a minute. So first, let's look at some arc sectors. Okay, so we want to find the shaded area. It's an arc sector. So this will be 90 over 360, because this angle is 90, times pi times radius squared, so that's 1/4, times 16 pi, which is equal to 4 pi. This one over here, this is 45 plus 90. So overall, it's 135 degrees we want out of a total of 360 times pi times 2 squared. 135 over 360 reduces to 3/8 times 4 pi. And I can cancel here. I end up getting 3 pi over 2. This angle is 45 degrees. That's the amount of the entire circle we want, times pi times 3 squared. So this is the portion of the entire circle we want. So that's 1/8 times 9 pi, or 9 pi over 8. And then for this portion, let's see, this is 120, which makes this angle 60, because you've got to subtract from 180. The radius is 6, so we've got, let's see, we've got 60 over 360 times pi times 6 squared. Well, this reduces to 1/6 times pi times 6 squared. I'll cancel the 1/6 with one of the 6's, and I'm left with 6 pi. Okay, getting on to some segment problems, a little bit more challenging now. All right, so what we have here is this blue arc segment we want. This is 60 degrees. That's a 4. I already drew in this vertical line. You're going to need that. So to get the segment area, you've got to do sector minus triangle. Here's our sector formula, minus here's our triangle formula. Okay, so to get the sector, that's the entire piece of the pie, so that's going to be an angle of 60 over 360 times pi times the radius squared, where the radius is 4. So we plug everything for our sector, minus, well, okay, now I need to get the base and the height of this triangle. So that's why I cut this in half. This becomes 30 degrees. This is 60. To go from the longest side, opposite the 90, to the shortest side, in a 30, 60, 90, divide by 2. So 4 divided by 2 is 2. To go from the 30 to the 60 side, you multiply by a radical 3. So now I know that this is also 2 over here. So I have a half, a base of 4, 2 plus 2 is 4, and a height of 2 radical 3. So half times base times height for my triangle, and I simplify this piece, and I get 8 pi over 3, minus, I simplify this piece, and I get 4 rad 3. To go any farther, you need a calculator. Okay, for this one, again, I want to get the segment, so sector minus triangle. This is our sector formula, minus our triangle, half base times height. Now, this is a 90-degree angle. and we know the radius is 6, so we'll plug in 90 for theta, 6 for our radius. In this case, pretty simple. The radius is 6, therefore this must also be 6. I don't have to cut this down the middle because I've already got a base and a height. They're at right angles, so I can just do half times base times height, half times 6 times 6. I reduce this, simplify that down, I get 9 pi minus 18. Last one. Okay, I want to find this arc segment here. So I've already drawn a little bit of this for you. Okay, so that's our sector, and minus, and we've got our triangle, half times base times height. So we've got a radius of 4 because that's half of 8. So this is 4. I've drawn in this. We know that if this is 60, this is 120, which makes this piece 60 here, and this 30. So the side opposite the 90 is 4. So to go to the 30 side, you divide by 2. To go from the 30 to the 60, you multiply by rad 3, which makes this 2 rad 3 also. So, okay. So this angle here is 120 with the radius of 4. So that's how I get this piece. Minus, and then to get this whole triangle, it's 1/2 times my base, which is 4 rad 3, 2 rad 3, and 2 rad 3. So 4 rad 3 times my height, which is 2. And then I do some cancellations, simplifications, and I get down to there.